Welcome viewers. In this video we will see the solved problem based on the RLC series circuit. Resistor, inductor and capacitors are connected in series. For that circuit we will see the solved problem. First we will see the problem 1. A coil of resistance 10 ohm and inductance 0.1 Henry is connected in series with a capacitance of 150 microfarad across a 200 volt 50 Hz supply. Calculate the inductive reactance of coil, capacitive reactance, current and power factor. We need to find these parameters. So the given data are the resistor value is available 10 ohm, inductor value is 0.1 Henry, capacitor is 150 microfarad, that is 150 into 10 to the power minus 6 farad. Micro means 10 to the power minus 6. The voltage is 200 and the frequency is 50 Hz. Now we will find the parameters one by one. The first one, inductive reactance. Inductive reactance is XL. XL equal to 2 pi F into L. So 2 into pi into the frequency is 50 and the inductor value is 0.1. So by solving this we will get XL equal to 31.4 ohm. Then we will go to the capacitive reactance. Xc equal to 1 divided by 2 pi F into C. So 1 divided by 2 into pi into the frequency is 50. The capacitor value is 150 into 10 to the power minus 6. So by solving this we will get 21.2 ohm. So the capacitive reactance is 21.2 ohm. Now we will find the reactance. The reactance X is nothing but XL minus XC, difference between inductive reactance and capacitive reactance. So these two are we already calculated. So inductive reactance 31.4 minus capacitive reactance 21.2, that is equal to 10.2 ohm is inductive, because the inductive reactance is more, capacitive reactance is lesser. So this will act, the circuit will act as a more inductive, so that it is given as inductive. Then we will find the current. Before finding the current, first we will find the impedance. Impedance, the magnitude of Z equal to square root of R square plus X square. From impedance triangle we can find this relation. Now we will substitute R equal to 10 and X equal to 10.2. So square root of 10 square plus 10.2 square. By simplifying this we got 14.28 ohm. So this is also inductive. So from the inductance value we can easily calculate the current. Current I equal to V divided by Z, voltage divided by impedance. So 200 divided by this impedance, what we calculated, 200 divided by 14.28, that is equal to 14 amps. The current flowing through the circuit is 14 ampere. Now we will find the power factor. Power factor is nothing but cos pi, that is equal to R divided by Z. One formula is available from the impedance triangle. So R value is 100, Z value is 14.28. By simplifying this we got 0.7. It is lagging. Why it is lagging? The circuit is more inductive. For inductive circuit, current is lagging the applied voltage. So that this power factor is 0.7 and given as lagging. So now we calculated all the parameters. We can go to the second problem. A coil of power factor 0.6 is in series with a 100 microfarad capacitor. When connected to a 50 Hz supply, the potential difference across the coil is equal to the potential difference across the capacitor. Find the resistance and inductance of the coil. So one capacitor is available 100 microfarad. The power factor is given. And another condition given is potential difference across the coil is equal to potential difference across the capacitor. We need to find the resistance and inductance of the coil. So from the given diagram we can easily understand. So this is the coil that is connected in series with the capacitor. So this coil contains inductance as well as resistance. Normally the coil means inductance, but it has some amount of resistance also available. So this is R and L connected in series. This combination is the coil. that is connected in series with the capacitor. So the condition given is the voltage across the coil is equal to voltage across the capacitor. V coil is equal to Vc. So that is a one condition given. And power factor is given as 0.6. The capacitor value is given 100 microfarad, that is 100 into 10 to the power minus 6 farad. The frequency is 50 Hz. So the problem is we need to find the value of resistance R and inductance L. So this R is the resistance of the coil, L is the inductance of the coil, Z coil is nothing but impedance of the coil, total impedance of the coil, right. So from the given condition we will start the problem. V coil equal to Vc, voltage across the coil is equal to voltage across the capacitor. So V can be written as I into Z coil, V equal to IR. Similarly Vc equal to I into Xc. So I got cancelled. So Z coil equal to Xc. The Xc formula is available, 1 divided by 2 pi Fc. So we can substitute the value, 2 into pi into the F is 50 Hertz, the C is 100 into 10 to the power minus 6. The capacitor value also given. So by simplifying this, we got Z coil equal to 31.8 ohm. The impedance of the coil is 31.8 ohm. So we calculated the impedance. Then another value given is cos pi coil, that is the power factor of the coil is 0.6. So this power factor cos pi can be written as R divided by Z coil, R divided by Z, here R divided by Z coil. From the impedance triangle, the formula is available, power factor equal to R divided by Z. So that is equal to 0.6. Now we cross multiply this, so that R equal to 0.6 into Z coil. So Z coil value is already available, 31.8. So R equal to 0.6 into 31.8. So by multiplying these two, we got 19.08 ohm. So the R value is now we calculated. R equal to 19.08 ohm. Now we'll go to the inductor value. For inductor, first we will calculate the Z coil. Impedance of the coil equal to R square plus XL square. So by square on both the side, Z coil square equal to R square plus XL square. We need XL square, so we can write Z coil square minus R square. Right? This R square is taken into that side. So XL square equal to Z coil square we already calculated 31.8. R value also in just now we calculated 19.08. So by simplifying this, we got 25.44 ohm. The inductive reactance XL equal to 25.44 ohm. This inductive reactance also written in another form, XL equal to 2 pi F into L. So the inductive reactance we calculated 25.44, that is equal to 2 into pi into the frequency is 50 into L. This L is we needed. So bring this term in the denominator. So L equal to 25.44 divided by 2 into pi into 50. So by simplifying this, we got 0.081 Henry. So that can be written as 81 Henry, that is millihenry. Milli means 10 to the power minus 3. So now we calculated the inductance value also. So in this problem we calculated resistance and inductance of a given coil. By based on the given condition, the value of R and L is calculated. So in this video we discussed the solved problem based on the RLC series circuit. Thank you.